Now, another important component is the valve positioner, right? So, as you can see in this diagram, the positioner is connected with a feedback link, which is interconnected with the valve coupling. Right? So, as the coupling moves, the control valve moves, the coupling will move, and in turn, this feedback will be given to the positioner. So this feedback link, it helps the positioner to measure the actual valve position, right? And it creates a force balance such that to maintain the control valve in that particular fixed position. So this adjusts the valve opening to match the desired flow rate. So if it is an electro-pneumatic positioner, we can directly give the 4 to 20 milliamp signal to the positioner. So this positioner will be having an I to P converter which converts this 4 to 20 milliamps into either 3 to 15 psi, whatever the desired bench set which is required for the control valve. Now, so the flow, now it can be regulated through the valve plug. Now, how much flow will be output based upon the valve movement? Right? So, the valve movement in comparison with the output flow, we call it as a CV, right? That is the process flow at a standard condition. So we are going to compare the actual valve flow versus the valve movement versus the output flow. So this is decided based on the design of valve and plug trim. So this plug trim, it determines the flow characteristics. So now we have three major classifications here, flow based on the flow characteristics. One is linear, then equal percentage, and the other one is quick opening. So in case of a linear opening valve, for equal increments of valve opening, there will be equal increments of change in flow. Right? So if it is a 10% opening, then there will be a 10% increase in flow rate. So this is called as a linear flow characteristics. So if you plot this valve movement versus the the actual output flow, the graph will be a straight line. It will be linear straight line. Right? So this is the linear characteristics. If it is an equal percentage, for every percentage of valve opening, the same percentage of increment in valve flow will be occurring. So that is called as equal percentage. Whereas for a quick opening, even for a small valve travel, the output flow will be high. So it will be exponential to the valve movement. So for a small valve opening, there will be a higher output flow. So we can based upon the valve trim. If it is a butterfly valve, even for a small opening, the output will have a large flow rate. So in that case, the positioner will be having a quick opening type characteristics, right? And again, this valve trim controls the direction of flow through the valve. Either it is from bottom to top or from top to bottom.
Valve positioner. As the name indicates, control valve positioners are devices that helps in positioning the actuator of the control valve by increasing or decreasing the air pressure on the actuator. They are generally mounted on the side or top casing of the actuator. If there is no positioner, the pneumatic control signal goes directly to the actuator. As there can be other forces acting on the valve stem, the accurate positioning cannot be achieved. So, when accurate and faster control is required, a valve positioner is used. A valve positioner will have a mechanical feedback from the valve stem, which will inform the valve positioner about the exact position of the valve stem. The valve positioner compares the valve stem position with the demand generated by the controller like PLC. If the valve stem is incorrectly positioned, the positioner increases or decreases the air in the actuator until the correct valve stem position is achieved. There are mainly three types of valve positioners: pneumatic positioner, electro-pneumatic positioner, and digital positioner. Pneumatic positioner. Pneumatic positioner receives a pneumatic signal, that means air signal, typically of 3 to 15 psi from a controller like PLC. It then sends corresponding output pneumatic signal to a pneumatic valve actuator. Electro-pneumatic positioner receives an electric signal, typically 4 to 20 milliamperes or 0 to 10 VDC from a controller, and it then sends a corresponding output pneumatic signal to a pneumatic valve actuator. Electro-pneumatic positioner uses an I2P converter, the working of which we have already discussed in a previous video. Link of that video is there in the description. A digital valve positioner receives an electric signal, typically 4 to 20 milliamperes, heart, Profibus, etc. from a controller. It then sends a corresponding output pneumatic signal to a pneumatic valve actuator. Digital positioners are also called smart positioners. It uses sensors and microprocessors to position the valve actuator and to monitor and record data. Thus, they are very accurate.